Hello, I'm Mitchell Wilson. I'll be presenting the paper on autonomous navigation of a maze using a Pi camera. This is my method. I'm going to start off by going over the background. We were all tasked in the class to go through a maze autonomously using the same base kit from Parallax Incorporated, which you can see pictured here on the left or right. It comes with an Arduino shell, a Raspberry Pi, of course Raspberry OS, the two servos you see as the wheels, and a second wheel that is not shown here, but it's a sphere and not powered. A few assumptions we have to make before attempting this problem would be every maze can be solved by following a wall until the exit's found. That's in most literature, that's how they do it. And also specifically for using the camera, we need to assume that a visible edge will be made between the wall and the floor, or the floor and the ceiling, that we can then follow to determine where the wall is. Here's my functional state diagram. You can see we start by capturing image data. We take the image data and detect the edges out of it, or extract the edges. We then split the image into three regions: the left, middle, and right. Each section is summarized into one value that is then compared to see which one has the maximum, and that is the direction the robot will move. However, one side case would be when the left, middle, and right equal each other. So if it's an all red image or an all white image or an all black image, that's when that condition will occur, and when that happens, we'll move towards the right. That's just like a safeguard to ensure that if the robot gets stuck, it won't just sit there and flail or try to move forward into a wall. It will instead make some action to move out of the wall. So this picture showed here is what my goal was in edge detection, detection, I guess. It's from a paper that did a similar project of navigating a maze, also using a Pi camera. My method involved using the Sobel filter, which is referenced in the paper, but that filter is used most commonly for, they used it to extract icons from images, license plate data, several other small objects. So I thought this was a good starting point to use that filter, as well as the method of dividing into sections and choosing the direction based on how many edges are found. So in order to get the Arduino to move, we have to interface it, of course. So what I do is, because Arduino Uno only has 2 interrupt pins, I used pins 5 and 6 to, I guess, encode a value or an action. So on the screen is how I encode those actions. So if pin 5 and pin 6 are both low, the actions stop. If pin 6 high and pin 5 is low, you go left. Opposites right, and if they're both on, you just go forward. I included stop instead of backwards because I figured that if an object was detected, it would be easier to stop the robot and make it skid back and forth, left and right, than it would be to have another dedicated pin just for the backward. Here's the assembly of the robot. On the left is the initial prototype. I went through a few different design iterations where I decided that the LEDs were to indicate which direction it was going. That didn't work out very well, so I decided to scratch that idea, as you can see on the right, and I just went for a feed-forward approach of attaching the camera directly to a Raspberry Pi and all the wires just directly to the Arduino. This was just to get it done mainly, and to get a functioning product before I do anything fancy with it. One thing you can't see in either of these pictures, because I forgot to take a picture of it, is between the two wheels, pictured in, of course, both pictures, is where the camera is mounted. You can see where the ribbon goes in the top right. It goes below the Pi, where the Pi is mounted. And that's what's used for the Pi camera. That's where it's mounted. Here's my final demonstration. I don't know if this is being recorded. It's a minute long. The audio does not need to be on. You can see this is the video from where the object was not in the correct spot. However, you can see that it detected the object and was able to navigate around it. Right here, it kind of like freezes up because it's not too sure where to go, I think, or it keeps choosing the rest option, or in this case, it's turning to the right. Here's where you can see it's going forward. It encounters a wall. It has the condition of all the same values are 0. Here, I'm guessing the condition was to go right, and that's why it continued to go right. And then once it's able to detect where the exit is, it turns and is able to just pretty much go forward until it gets to the exit. You can see that the robot kind of stutters as it walks. This is mainly due because I didn't want to have like an out of control robot, mainly because if I had that delay longer to make it go forward on its own for a longer time, it would crash into walls more. So I decided to lower it to hopefully, avoid collisions as much as I can. So last little bit, it hits the wall a little bit, but then it's able to finish. Any questions?